far should gene editing go in transforming the human race? Humans have anywhere between 20,000 to 25,000 genes made up of DNA in their bodies, and when it was discovered that these DNA can be altered, the science and medical field were changed forever. Gene editing first began in the late 1900s, and major advancements were made in 2001 when CRISPR was discovered. CRISPR made it easier than ever to alter DNA sequences and modify gene editing or functions. It was later improved in 2012 when two Nobel Prize winners, Emmanuel Carpenter and Jennifer Doudna, discovered CRISPR-Cas9. With the combination of uncertainty and the ethical argument, gene editing should be monitored and only used for somatic engineering for the time being. But what does this necessarily mean? One of the first major instances when DNA or gene editing was used was when a Chinese scientist created two designer babies in hopes to reduce odds of inheriting HIVs from their father. While genetic engineering was the basis of this controversy, it was more so the methods in which he did so, germline editing. Another instance when gene editing was used is when Victoria Gray, a 34-year-old suffering from sickle cell disease, had gene editing done on her body. This disease affects millions of people across the country and appeared greatly successful. However, it eliminated not only symptoms, but the DNA causing the disease as well. So what's the difference between these two cases? It comes down to germline editing and somatic gene editing. In the instance in China, when the scientist began his studies on an embryo before the child was even born or even developed, it affected nearly every cell in the body. Changes were hereditary and were passed on to future generations. Whereas in Victoria Gray, she was a 34-year-old and had the capability of making her own decisions. Through somatic gene editing, it not only affected the targeted genes causing the disease, somatic cells are non-reproductive cells, meaning it will not affect other DNA. It is non-hereditary and will be passed on to future generations as well. Somatic gene editing can be used to fight any DNA-strung disease and has already been used to fight vision defects, malaria, sickle cell disease, and even cancer. While germline editing is outlawed in several governments, including the US, somatic gene editing is not. One of the major areas where somatic gene editing has been studied is with cancer treatments. CRISPR is becoming a mainstream methodology used in many cancer biology studies because of the convenience of the technique, said Jerry Lai of NCI's Division of Cancer Biology. There was a study done at the University of Pennsylvania that in 2019 that incorporated two cancer patients. One was suffering from multiple myeloma and the other was suffering from metastatic sarcoma. These appeared somewhat effective, however, minor side effects were detected along the way, and one actually went back to their original state before the procedure. This indicates that while we know it can work, we may just not know enough currently. More than 4.5 billion people go through life suffering from a genetic disorder of some sort. Gene editing has the capability of treating nearly every DNA-borne disease. So what's holding us back? It comes down to society. Society is ultimately going to have to decide whether or not we follow through on gene editing. Germline editing would transform the human race and would likely nothing would be the same. Money is a huge problem as it would create an even larger social divide, and those who have money and those who do not have money would be separated. There is no consent in germline editing, and those who are affected by these gene editing modifications do not decide whether or not they are going to be affected. Lastly, we just don't know enough to go through on gene editing and to incorporate it into our daily lives. Somatic gene editing is where we stand today, but it may not be where we stand in the future.
Thank you. What information did you need you weren't able to find or locate?
I couldn't necessarily find how effective CRISPR is because it hasn't been used. So this kind of alters how the future will be. So I went around with reframing my question on how it will be like in the future, whether instead of where it is now.
Okay, thank you. What are the implications of your findings to our community?
The implications of our findings in the community is somatic gene editing has already been used, as I said in the case with Victoria Gray. That is likely to be even larger, that's going to be larger in the near future, and people in our immediate communities could even be affected by this gene editing. So.
Okay, thank you. Another round of